In this presentation, we will discuss the substitution method for solving systems of equations. Recall that a solution to a 2 by 2 system of linear equations is an ordered pair of the form x, y that satisfies both equations. For example, the point 2, 5 is a solution to the system with equations x plus y equals 7 and y equal 3x minus 1 because x equal 2 and y equal 5 make both equations true. We will first describe the substitution method by a series of steps and then illustrate the method by example. First, isolate or solve for one of the variables from one equation. Next, substitute the expression from step 1 into the other equation. This creates an equation with only one variable. Solve the resulting equation. Then substitute the value found in step 3 into the expression from step 1 to find the value of the remaining variable. Finally, check the ordered pair in both of the original equations. Let's illustrate these steps with an example. Solve the system with equations x plus y equal 4 and minus 5x plus 3y equal minus 12. We will carefully apply the steps itemized previously. First, isolating x in the first equation yields x equal 4 minus y. Then substituting into the second equation and solving for y produces minus 5 times the quantity 4 minus y plus 3x equal 12. Distributing the negative 5 gives minus 20 plus 5y plus 3y equal minus 12. Collecting like terms gets minus 20 plus 8y equal minus 12. When we add 20 to both sides of the equation, we get that 8y equals 8, so that y equals 1. Then substituting y equal 1 into the equation from step 1 yields that x equals 4 minus 1, which is 3. Finally, we see that the ordered pair 3, 1 checks in both original equations. Let's compare what happens graphically in a linear system with what happens algebraically when we attempt to solve the system. Recall that the graph of a 2 by 2 linear system consists of two lines. Let's return to a previous example with equations x plus y equals 7 and y equal 3x minus 1. The graph of the system consists of the graphs of the line x plus y equals 7 and the line y equal 3x minus 1. The point of intersection, 2, 5, is the solution to the system. In general, there are three possibilities for the graph of any 2 by 2 linear system. We could get intersecting, parallel, or coincident lines. In the case of intersecting lines, solving the system algebraically produces the unique solution xy. What happens algebraically in the other two cases? In the case of parallel lines, the algebra produces a contradiction which indicates there is no solution to the system. In the case of coincident lines, the algebra produces an identity which indicates there are infinitely many solutions to the systems. Let's consider examples of each case. Suppose we want to solve the system with equations y equal 3x minus 2 and y equal 3x plus 5. Clearly, these equations represent parallel lines, and the system has no solution. However, our intent here is to illustrate what happens if we don't notice this and proceed with an algebraic solution. Both equations already have y isolated, so substitution produces 3x minus 2 equals 3x plus 5. Subtracting 3x from both sides leaves that minus 2 equal 5. This last equation is a contradiction. We often mark a contradiction with a symbol of an X inside a circle as shown. A contradiction typically indicates a mistake of some sort. In this particular case, the mistake is trying to find a solution that does not exist. Therefore, there is no solution to the system. Now let's consider the other extreme case example with dependent equations. Let's solve the system with equations y equal 3x plus 2 and 2y equal 6x plus 4. Again, our intent is to illustrate what happens algebraically in this case. The first equation is already solved for y, so substituting y equal 3x plus 2 into the second equation and solving for x produces 2 times the quantity 3x plus 2 equals 6x plus 4. Distributing the 2 on the left-hand side of the equation gives 6x plus 4 equals 6x plus 4, which we probably notice is an identity. If we continue solving and subtract 6x from both sides, we get 4 equals 4. Either way, we have an identity. An identity is a true statement for all real values of x. Therefore, every real value of x produces a solution, xy, and there are infinitely many solutions to the original system.